Welcome to 6th grade math. I'm Mrs. Jack from Gresham Middle School, and today's lesson is going to be on representing equations in tables and graphs. So let's go ahead and get started. I know last week you had a challenge problem, and so we're going to go over that challenge problem today to make sure that everyone understood how to find some solutions for it. So let's read the directions. It says, using the digits 0 to 9 at most one time each, fill in the boxes to make a true equation. Well, I'm going to start a little bit backwards because I'm going to write on this side first, and I'm going to show you how to figure out what this side could be. So I'm going to take this number and this number, 6 and 18, and I'm going to factor them out first. So let's take the 6. Factors of 6 are 1 times 6 is 6. 2 times 3 is 6. So our factors are 1, 2, 3, and 6. For 18, our factors are 1, 2, 3, 6, 9, and 18. Now what we want to do is we want to see what they have in common. They have a 1 in common, a 2 in common, a 3 in common, and a 6 in common. Now, since the directions tell us that we can only use our numbers one time, we can't use the 1 because we already have it listed here, and we can't use the 6 because we already have it listed here. So let's go ahead and try the 2. So we want to think about pulling this common factor out. And if you do that, you're going to put it on the outside of your parentheses. And then you're going to say 2 times what is going to give you 6, 2 times 3, and 2 times what is going to give you 18. That's going to be 9. So this is called the distributive property. What we've done is we've distributed this 2 to everything inside the parentheses. 2 times 3, 6, plus 2 times 9 is 18. And we want to know, is it equal to 6 plus 18? This side is 24, and this side is 24. And therefore, we do have a pair that matches. Now, there are 23 other answers that you could have gotten that would have been correct to this kind of a problem. Let me write you one more so that you have at least one more to go by. If I factored out a 2, let's go with factoring out a 2, and on this side, I'm going to have a plus and a plus, okay? Equals 14 plus 6. So if I found the factors of 14 and 6, I could take a 2 out, and then I can say 2 times 7 is 14, and 2 times 3 is 6, and I have my equal sign, 14 plus 6, and 14 plus 6 is 20. And 20 on both sides means that they are true equations. So there's 2 examples of some possibilities to those examples for the challenge problem. Let's go ahead and get started on our lesson today. So it says represent equations in tables and graphs. And you'll see I've put some other kind of learning stuff on here, and we're going to go over that in just a minute. But first, I think I'm going to zoom this in a little bit so you can see it better. And we're going to read what it says. It says, a baby gorilla had a mass of 2,620 grams at birth, 2,960 grams after 10 days, and 3,300 grams after 20 days. What is the average number of grams that the baby gorilla grew each day during the first 10 days and during the next 10 days? Well, let's underline some important information in this reading. I see that a baby gorilla at birth weighs 2,620 grams. In 10 days, it weighs 2,960 grams. And after 20 days, it weighs 3,300 grams. Now, let's see what it's trying to ask us. What is the average number of grams that the baby gorilla grew each day? All right, grams each day in the first 10 days and during the next 10 days. So we want to know how much it grew in the first 10 days, each day, and then the next 10 days. So I thought we would start by using a table. And in the table, you'll see that I put X and Y. And the X is going to equal the age or the days. And the Y is going to equal the mass in grams. So let's look and see what we have here. The age you are at birth is, yes, you're a 0. You're not a day old, so you're 0. So you have 0, and the baby gorilla weighed 2,620 grams. And then in 10 days, the baby gorilla weighed 2,960 grams. And after 20 days, the baby gorilla weighed 3,300 grams. And that's what it asks us in the table. So let's go ahead and try to figure out how much did the baby grow in 10 days. So we can take the number here, because this is 10 days. It increased 10 each time on the left. We don't know what it's increasing here on the right yet. So let's go ahead and figure it out. We have 2,960 minus 2,620 grams. This one was 10 days. This is when it was born. And we want to know how much is that going to equal. When we subtract the two, we should get 340 grams, and that would be in 10 days. But it didn't ask us just like how many in 10 days. It asked us what was the average number of grams the baby gorilla grew each day. So if this is for 10 days, we know we can find our equivalent ratio, because we can go down to a 1. If we divide 340 by 10, we get 34. So the baby gorilla grew 34 grams per day. And that is just in the first 10 days. So now we want to know, how much did it grow in the next 10 days? That's the next part of the question. So we see we have 3,300 grams, and we're going to subtract it from 2,960 grams. And that was 20 days minus 10 days. And when we do the subtraction on that, we do come up with 340 in 10 days. We want to know how much 1 day is, so we're going down to that rate, unit rate, and we see that that is 34. So 34 grams per day. Now, the answer to this question says the average growth for the baby gorilla is, and we can fill in what we found up here. We found out the answer right here. The average growth for the baby gorilla is 34 grams per day for both the first 10 days and the next 10 days. Now let's use the information we have in the table or in our calculations or computations, and let's talk about the turn and talk. If the baby gorilla continued to grow at the same rate for the first month after birth, what would be the baby gorilla's mass 26 days after birth? 26 days. We want to know how much the baby gorilla weighed after 26 days. So our table only goes to 20. So let's add a 26 here. Now there's several ways that you can do these calculations, but I'm going to just use what we already have. So we know 20 days is 3,300 grams. And we need to know what 6 more days are. But the easy thing here is that we know that we need 6 more days. But according to this, we know that we have 34 grams per day. So if we take 34 and we times it by 6, we get 204. And then all we'd have to do is add the 204 to the 3,300 to get how many 26 days it would weigh. So it weighs, the baby gorilla weighs 3,504 grams after 26 days. So that's the way you would solve that problem. And I'll leave that there so you can kind of see it and finish writing. You should have this on the, or in the packet that you picked up or you printed. All right, let's go on to the next page. Let's go to our performance task page. All right. Let me move this down a little bit so that you can see where we are. We are here. And I'll blow it up where we can read it a little bit more. All right. It says answer the questions. So let's read about Wahida. It says Wahida wants to buy a skateboard. She has $15 in savings. A skateboard costs $75. How much more money does she need? Write and solve an equation to represent the situation. Well, I'm going to underline what I know. I know she has $15 in her savings. And I know she wants to buy a skateboard that costs $75. Well, the question says, how much more money does she need? Well, we know that the money that she needs is going to be our X because we don't know how much money she needs. So we're going to let that be our variable. But we know that she has $15 in her savings. And we know that the skateboard costs $75. So our equation should be X plus 15 equals 75. Now let's write a solution. We have 75 minus 15 because she has 15 in her savings. And this will give us the answer of how much more money she needs. So she needs $60 more. And I'll just write that right there. She needs $60 more to buy her skateboard. Suppose Wahida wants to have some money left over after buying the skateboard. What does she want? She wants to have some money left over. Some money left, okay? Write an inequality to show how much Wahida needs to earn. So an inequality is just comparing things with the greater than, less than, equal to symbols. And so we know that X was our variable. She has to have $60 at the very least, the minimum, to buy that skateboard. But because it says that she wants to have some money left, then our X has to be greater than 60 because she wants to have money left over after she buys her skateboard. If she just had $60, then she would not be able to have any money left over. So she would have, let's say if she had $61, she would have $1 more than 60. So X, whatever your number is, has to be greater than 60. Good job. Now let's look at number 3. It says to earn money for the skateboard, Wahida decides to run a lemonade stand. If she sells each glass of lemonade for $1.50, how many glasses of lemonade will she need to sell? Write and solve an equation to find the answer. Well, let's see what we have here. She decides to run a lemonade stand. She's going to sell glasses of lemonade for $1.50. So we have $1.50. Does it tell us how many glasses she sells, or that we need to decide that? So we need this to be a G. $1.50 times G, because we don't know the number of glasses she's going to need in order to earn $60. So the way we would solve that is we say 60 divided by $1.50. And if we solve that, we would see that we had the number 40 glasses equals $60. If you divide 60 by $1.50, you would get 40. Okay. Let's move this up a little bit more. Wahida mixes water with some lemon juice to make lemonade. Write an equation to represent how much lemon juice is needed when Wahida uses 10 ounces of water. Well, let's look at the graph down here, the table. We see the water and the lemon juice here. So we have our X here and our Y here. And we see that for every water, there is, it increases. So we have water, 6 ounces, lemon juice, 2. And if we divide 6 by 3, we get 2. If we divide 9 by 3, we get 3. If we divide 12 by 3, we get 4. If we divide 15 by 3, we get 5. So each one of these are dividing by 3. So let's go ahead and write that Y has to be equal to X, because we don't know yet. We're going to use 10, but we don't know the water. And it is dividing it by 3. Every time we've divided it by 3. So that's the pattern. So if we have X, Y equals X divided by 3, and we substitute 10 for our X, we're going to do that right here. Y is equal to 10 over 3. And it just asks us to write an equation to represent how much lemon juice is needed when Wahida uses 10 ounces of water. So this is our equation. Y equals 10 divided by 3. And we can also say that Y is equal to 1/3 times X. And to prove that, if we put 10 in for X, we had Y is equal to 1/3 times 10. And if we solve that, we have Y is equal to 10 over 3. So we can also say that Y is going to be 1/3 of X. All right, let's move on. Number 5. The amount Wahida earns is related to the number of glasses of lemonade she sells. I want you to identify the independent and the dependent variables in the situation. So independent variables just mean that it's independent. It doesn't have to have any help. It's always going to be the same. So the x-axis represents the independent, and that's going to be the glass of lemonade. And then our y-axis for our graph would be the dependent, And that would be her earnings. How much money she earns. Okay, that's how we solve that. So independent is the glass of lemonade. You know, she either has 1, 2, or 3 glasses of lemonade. And how much she makes depends on how many of those glasses she sells. Then here for B, it says write an equation representing the amount Wahida earns in relation to the number of glasses of lemonade she sells. Well, we know that each glass of lemonade cost $1.50. And we know that she's going to sell some number of glasses. And that is going to equal how much she earns. Okay. We could also write it as 150 X is equal to Y, how much she earns. Okay. Now, in letter C here, it says, in which quadrant of a graph would her data appear, and explain it. So in order to know that, you have to have a graph. So I have made us a little graph to help us figure this out. So let's go ahead and bring this down a little bit so you can see it. And I'll get my graph out here. Now, let's talk about this. This is called a coordinate plane. For many of us, we already know this, but it wanted to know which section the information would be graphed in. So the graphing looks like this. We have ordered pairs. That's what this represents, ordered pairs. In quadrant 1, you have positive numbers and positive numbers. So your X is positive and your Y is positive. X is positive, Y is positive. And if you have 2 positive numbers, they'll be in quadrant 1. Quadrant 2, your X is going to be negative. Your Y is going to be positive. Quadrant 3, they're both negative numbers. Quadrant 4, you have a positive X and you have a negative Y. So, which quadrant would the sales of the lemonade be in? Well, we could say that this is the glass and this is the earnings right here. So, if her ordered pairs are 1 glass for $1.50, 2 glasses for $3, 3 glasses for $4.50, and 4 glasses for $6, then all of these pairs will fall in the quadrant 1. So let's go ahead and write that. It says, in which quadrant of the graph would her data appear? That would be in quadrant 1. And I'm going to put because, and it's really simple. You can't sell negative glasses of lemonade. You can't sell negative glasses of lemonade. Just not happening. All right, let's see the last question here. It says, graph the equation on a separate sheet of paper. Be sure to choose the appropriate scale for the X and Y axis. Well, we'll go back to this. And we'll use these as our ordered pairs because here's 1 glass, 2 glasses, 3 glasses, 4 glasses. So if we have 1 glass, 2 glasses, 3 glasses, and 4 glasses, that's our X right here. Our Y are the dollar amounts. So we have $1.50, we have $3, we have $4.50, and we have $6. So to graph that, we go out on our x-axis first and we go up to our $1.50. We plot our point. Then we're going to go out to 2 glasses and go up to $3. Go out to 3 glasses, go up to $4.50. And go out to 4 glasses and go up to $6. And that's how we graph those sales of lemonade. And if we drew our line through, we could actually figure out how many more glasses and how much more money we would earn by the glass. Okay, I'm going to show you again your answers. Let me back that out just a little bit for you. And I'm going to circle the answers in purple so you can see that these are the correct answers. All right, if you should have any questions, please contact your teacher. I hope you have a great rest of your day.